Okay, there's some more factoring methods, and this is factoring method number 6, and these are general trinomials, and these are usually the most challenging ones. But we have a nice little method that we can use on these, so we'll demonstrate this, and I'll give you all the possible sign combinations like I did with simple trinomials, plus, plus, minus, plus, plus, minus, and minus, minus. So all the different sign combinations. So here's a general trinomial, and we try all of our other methods and nothing's going to work. It doesn't have a common factor. It's not difference of perfect squares. It's not a trinomial square. It's not a simple trinomial. We can't use four-term grouping, so we're stuck with general trinomial at this time. So first of all, this method, we just multiply the first number times the third number, just the numbers. 3 times 21. That's the leading coefficient and the constant term. And we get 63. So what we're looking for is two numbers that multiply to give 63, and they have to add up to be the same as this middle number, 16x. So we're using all three numbers, all three coefficients anyway, 16. So we analyze the signs. If they multiply to give a positive, the signs will be the same. If they add it to be a positive, they both have to got to be positive. So you analyze your signs like we did with simple trinomials. Analyze the signs. And we need two numbers that multiply to give 63. So we can try 1 times 63, but they don't add it to be 16. We can try 2 doesn't go in there. 3 goes into 63 21 times. That's not going to work. They don't add it to be 63. That would be 24. 4 doesn't go to 63. 5 doesn't go to 63. 6 doesn't go to 63. 7 does go in there 9 times, and there we go. Those two numbers work. So I can just use 9 and 7. Signs are the same. I'm sorry, 7, 9. Same thing. And that's going to work. So now I'm going to rewrite this middle term. Instead of 16x, I'm going to write it as 7x plus 9x. Like, see, that's the same thing as 16x. Then I'll bring down my 3x squared and my plus 21. And now we just look to group this, and we can use the four-term grouping method. Group it right down the middle. And out of these two terms, it looks like I can take out an x, just an x. And what's left is 3x plus 7. And then out of these two terms, it looks like I can take out, and we always take out this sign, so a positive. And it looks like I can take out a 3. And if I do, what's left? 3x plus 7. Now we have a common binomial factor of 3x plus 7, so I can factor that out. And what's left? X plus 3. So there you go. And then you can always multiply it out to check. 3x times x is 3x squared. 9x plus 7x is 16x. And 7 times 3 is 21. So it checks out. Okay? So a relatively easy method. Once you get the hang of it, and do your little side work over here. All right, let's try the next ones. Okay, so we're going to multiply again the first term, or the leading coefficient times the constant term, times the constant. That's going to be 7 times 3, so that's going to be 21. So we're looking for two numbers that multiply to give 21, but they have to add up to be negative 22. So if they multiply to give a positive, their signs would be the same, but if they add it to be negative, they're both got to be negative. So I'll put my signs in both negatives. And any numbers that multiply to give 21, so I can start with 1 and 21. And right away that works. So those would be both negative, so I could write negative 1 and negative 21. Negative 1 and negative 1. I'm sorry, negative 22. Negative 21, pardon me. So negative 1 and added to negative 21 is negative 22. All right. And negative 1 times negative 22 is positive 21. So that satisfies both conditions. So now I just rewrite this negative 22 as negative 1 x and negative 22x. I'm sorry, negative 21x, pardon me. Okay, so negative 1x and negative 21x is negative 22x. So same value. And then I'll bring my 7x squared and my plus 3. And then we'll just group down the middle, 4-term grouping. Out of these two terms I can factor out, it looks like just an x again, x, and I have what's left. 7x minus 1. And then out of these two terms I can factor out, and we always take out the leading sign, so I'll take out a negative 7. I'm sorry, negative 3. 3 goes into 21, 3 goes into 3. And what's left, if I take a negative 3 into 21, it goes 7 times, so 7x. And if I take a negative from a positive, it leaves me with a negative 1. I can always multiply that out. A negative 3 times 7 is negative 21, and negative 3 times a negative 1 is positive 3. And now you see we have a common binomial factor. We always will. If we find the two numbers that satisfy this criteria, it's always going to work. Now, if you don't find the two numbers that satisfy this criteria, then this is what we call prime. We can't factor it. We have to use some other method. If it's an equation, we use a different method. If we want to factor it, it can't be factored. So there you go. Okay? So those are when we have a positive positive or negative positive. Now let's see what happens if we have a negative in the last spot. So here's two more examples. So again, we'll multiply the first term. We have identified this as a general trinomial, so we'll multiply the first term times the third term. So that's going to be 9 times negative 7. That's negative 63. So again, I need two numbers that multiply to give negative 63, and they have to add up to be positive 18. So since they multiply to give a negative, the signs would be different. Since they add it to be a positive, the larger will be positive, so I'll put positive, negative, positive, negative. And multiply to give 63, so we can start with 1 times 63. Now, since the signs are different, they're going to differ by 18, not add up to be 18. All right? So these two numbers that add up to be 18, the signs are different, so they'll actually be different. And their sum will be 18. And these differ by 62. 2 doesn't go in there, 3 goes into 63 21 times, and these do differ by 18. So 21 minus 3. 21. Now if you multiply these, a positive 21 times a negative 3 is a negative 63, but a positive 21 added to a negative 3, 21 minus 3 is 18, so they satisfy both conditions. So now I know I can factor it. And I'll rewrite that 18 as 21x minus 3x. And then we'll bring down my 9x squared and a negative 7. And then we'll do our 4-term grouping. And out of these two terms, it looks like, in fact, I can factor out a 3x. And what's left is 3x plus 7. Now, out of these two terms, remember, we always factor out that leading sign, so I'm going to take out a negative. And it doesn't look like there's anything else, so I'm just going to make it a negative 1. And then I have 3x plus 7, because I took out a negative 1, and you can always check this, a negative 3x, negative 7 if you multiply it out. It should always multiply out and check. Then we have a common binomial of 3x plus 7, so I'll factor out 3x plus 7, and what's left is 3x minus 1. And you can always check this by multiplying it out. 3x times 3x is 9x squared. And then 21x minus 3x is 18x, and 7 times the negative 1 is negative 7, so it checks that. Now if this is going too fast, you can always pause it, go back, stop and take a look at it. Everything should make sense. The main idea is this work over here. All right, and our last one, 6 times negative 10. Leading coefficient times the constant term, and that's going to give me a negative 60. So I need two numbers that multiply to give a negative 60. And they have to add up to be negative 11. So since they multiply to give a negative, their signs will be different. Since they add up to be a negative, the larger one will be negative. So I always write my larger one first. Negative, positive, negative, positive. And then you have to multiply to give 60. So 1 times 60. But then because the signs are different, they're going to differ by 11. That's not going to differ by 59. 2 goes in there 30 times. No. 3 goes in there. They differ by 28. 3 goes in there 20 times. No. 4 goes in there 15 times. That works. These numbers differ by 11, so they're going to work. So this is going to be negative 15 plus 4. And just check this. A negative 15 times a positive 4 is a negative 60, but a negative 15 plus 4 is negative 11. So that's how we're going to rewrite this. Negative 15x plus 4x. And that's the same thing as negative 11x. And then I've got my 6x squared over here. I bring that down and I bring down my 10. And I'm ready to do 4-term grouping. And it will work. As long as I find the two numbers that satisfy this criteria, this will always work. So out of these two terms, it looks like I can take out a 3x. And 3 goes into 6 twice, so it looks like I've got 2x. 3 goes into 15 5 times, so negative 5. And it looks like out of these two terms, I can take out a positive, always this sign. Positive 2 goes into both 4 and 10. And what's left? 2 goes into 2x, 2x. 2 goes into 4x, 2x times, so 2x. 2 goes into 10 5. And there's my common binomial factor. So I got the 2x minus 5. That comes out. And what's left is 3x plus 2. And if you multiply that out, if you FOIL that out, 2x times 3x is 6x squared. Negative 15x plus 4x is negative 11x. And negative 5 times 2 is negative 10. So it checks out. So those are 4 good examples of the general trinomial method. It's a nice little shortcut. Works. Save you some time. And again, like I said, you can always pause these, go back, and look at them one at a time. Make sure you thoroughly understand them. It's going to help you a lot in the future.